Hello everyone, welcome to the lecture series of finite element analysis. This is Dr. Manoj Kumbhalkar. So in the very first lecture we will learn about the introduction to finite element analysis. So basically there are three methods for solving the engineering problems: analytical method, experimental method and numerical method. So analytical method is the classical approach, that is nothing but the design calculation which we are learn in the subjects like design of machine element, strength of material, heat transfer and a number of subjects. And it is 100% accurate method because we use the number of formulation to find out the required entity. Okay, so it's a closed form solution. We will get the closed form solution and it is complete in itself. Then experimental method is the correct procedure because we perform the experimentation on the physical model, but it's a time consuming process because we require a number of readings to finalize the required reading. Okay, also it is expensive because we require an experimental setup to perform the practical. Okay, physical prototype required 3 to 5 prototype required. Okay, so we require a physical model and also required to perform a number of experimentation to finalize the required reading. Okay, third method is the numerical method. Numerical is the mathematical representation and also it's an approximate technique. So finite element method is the numerical method. Okay, so therefore always it is says that finite element method or finite element analysis is an approximate technique. So therefore the result of finite element method must be verified by experimentally or we can say analytically. Okay, so these three methods are very important for the any analysis point of view. So sometimes we perform all the three methods or sometimes we perform any two methods among these three. Okay, so what is finite element analysis? The finite element method is a numerical technique to solve field problems in engineering and science. So we already discussed that it's a numerical technique. So to solve field problems, or we can say to find out the field variables like displacement, stress, strain. Okay, the technique has very wide application and has been used on problem involving stress analysis, fluid mechanics, heat transfer, diffusion, vibration, electrical and magnetic field. So many students are think that finite element analysis is only limited to the design only, but it is not limited to design. It can be used for the all the subjects of engineering. Okay, so like design engineering, thermal engineering, vibration and also electric and magnetic fields also. Okay, so if we go in the details of the finite element analysis tools or software, then we will check that how it can be used for the all the subjects. Okay, the fundamental concept involves dividing the body under the study into a finite number of pieces or subdomains called element. So first of all we discuss about that how the finite element analysis names indicates. Okay, so check that name, finite element analysis. So just see from the back side. First of all the analysis. So finite element analysis. So analysis indicates, it means what, this technique is used for the analysis purpose, not for the design purpose. Okay, second one is the element. So this technique is used by dividing the body into the number of parts, and the part of the divided body is called as element. So therefore we could say that element analysis. And then first word is the finite. So finite, it means what, we are going to divide the body into the number of parts, but not in the infinite number. We have to divide the body in the finite number of parts. So therefore we say that it's a finite element. Okay, so therefore the name, the subject name is finite element analysis. Okay, got it? So check that figure in this slide. This is the plate with curve shape at the bottom. So this body is divided into the number of parts, and the triangular part, that single triangular part is nothing but the element. Okay, and the corner point of that node element is nothing but the node. So the points which is shown in the circle are nothing but the nodes. Also given the numbering to that circles 1, 2, 3, 4, 5, 10, 15, 20, 25. So these are the nodes. Okay, and the each triangle part is nothing but the element. So particular assumption are then made on the variation of the unknown dependent variable across each element using so-called interpolation or approximation function. This approximated variation is quantified in terms of solution values at spatial element location called nodes. So if the load is applied over that plate, so there will be the deformation of each and every node. So due to the deformation of each and every node, the stress will be induced on the element. Okay, so therefore the basic advantage of the finite element analysis is that we will get an elemental or nodal solution. So we cannot say that only the single stress value is acting over the plate, which we studied in the strength of material. So in the if we apply the load on the bar, we can say that if the 100 Newton of force is applied over that much area, we will say that like 50 Newton per mm square stress is acting over that bar. But in the finite element analysis, we divide that bar into the number of parts. Okay, so if the 100 Newton of force is applied over that bar, then the we will get an elemental solution over that body completely. So we will find out where that maximum stress is acting over the bar. Okay, so that is the best advantage of the finite element analysis technique. So we will check some historical background. So here in the 1940, the structural in the structural engineering, they started the one dimensional. They started the analysis over the structure using the one dimensional element. So for example, the towers, bridges are the example of one dimensional element. Okay, in the 1950s they introduced the two dimensional element. So and started the using of stiffness method. Okay, but in the 1960, the scientist Klog, he used word finite element in his paper. So in his paper has been published in the American Society of Civil Engineering. So he used the word that finite element. So from that date, the technique name is given that finite element method. Okay, and in 1970s, three-dimensional element method has been introduced. Okay, so now in present days, it's very known method for the engineering applications as well as for the industrial application. So number of elements has been introduced, number of softwares are there now like ANSYS, Nastran, NISA, Abacus, Autodesk simulation. Number of softwares are available now. Hypermesh is the very best tool for the meshing purpose. Okay, so these are the some softwares. Now the basic phases of FEM which has been used in the every software. Okay, so the pre-processing, solution and post-processing are the three most important phases of the FEM. So these three phases are being used in all analysis softwares. Okay, so what it indicates? So pre-processing means, so when we are going to find out the solution of any entity, so over that one we have to do some process, like we have to, first of all we have to prepare a model. Thereafter we have to discretize the body. Discretization means what? We have to divide the body into the number of parts. So kindly take a note of that. Finite element method is works over the discretization method only. So if you will not going to discretize the body, or we can say if you are not dividing the body into the number of parts, the finite element method cannot be implemented. Okay, So discretization is the basic part of the finite element method, and it's also very vast area. We will see in detail in the practical. Okay. Meshing is very important. So in the pre-processing, what is required? First of all, the 3D model is required, that is modeling. Second one is the discretization, or we can say the divide the body into the number of parts. Third one is the material properties. We require material properties like modulus of elasticity, Poisson's ratio if we are going for the static structural analysis, and if you are going for the dynamic analysis, then some more parameters are required like density and some others. Okay. Thereafter we have to apply some load, or we can say we have to apply boundary condition. Okay. Boundary condition means that body will get fixed at some point, and if the load or torque is applied over the another point, so that is nothing but the boundary condition. So these all are included in the pre-processing. Okay. Second is the solution. Solution means what? With the help of the derivations, with the help of the mathematical equation, we will get some solution like displacement, stress. Okay. So that calculation has been carried out in the process of solution. And in post processing is nothing but the interpretation of the result. So how the results are required, in which form you require the results, that is nothing but the post processing. That is the most famous technique in the FEM is nothing but the contour plots. Okay. So we will get the results in the contour plots. It is shown in the colored shape. So the colored portion indicates where the stress or displacement is maximum, intermediate or minimum. Okay. So we will get that result in the post processing. There are basically 7 steps of finite element method. So first step is the discretization. Discretization means divide the body into the number of parts, divide the body into a number of parts and develop elements and nodes. Okay. Second is the select displacement function or solution approximation. It means what? We have to select one some mathematical method. Third step is the derive the element stiffness matrix and equation. So in how many number of parts you are done in the over that body. So for each and every element we have to prepare a stiffness matrix. Okay. And whatever will be the number of element, so for all the elements, if you have prepared the stiffness matrix, thereafter you have to assemble all the matrix, that is called as the global stiffness matrix. Okay. After that applying that global stiffness matrix, you have to apply that method of some method like principle of minimum potential energy. By using that method, you can find out the unknowns. First unknown will be the displacement, that is nothing but the degree of freedom. Okay. Thereafter you will get the elemental strain or stresses. Okay. So and last step will be the interpretation of result, that is nothing but the post processing. So it has been cleared in the next slide. We give the some simple example. First is we give the example of cube only. Okay. So first you have to model that cube in FEA with some dimensions. Second step is to give the material properties. Material properties involves density, Poisson's ratio, Young's modulus and some others. Okay. Third step is to meshing. Okay. Meshing means dividing that body into the number of parts and joined with the help of nodes. Okay. So how many number of elements and how many number of nodes are there, based on that the results will vary. Third step is the fourth step is the apply boundary condition. Boundary condition means where the body is getting fixed or displacement and where the load is applied. So that is nothing but the boundary condition. Fifth step is the solution. So with the help of mathematical equation, the solution will get carried out. In the softwares, the solution will be carried out at the back end. And last step is the post processing. So such type of result will obtain in the FPS software. So that color plot is nothing but the color zone is nothing but the contour plot. Okay, so in the at the bottom it is shown as the color line. Okay, so that color line indicates the from which the range of the value. Okay, if this is the result of stress, the range of the stress is starting from blue color to the red color. So in this diagram, blue color zone represented as the minimum stress and red color zone is represented as the maximum stress. Okay, then the common types of element for meshing. So meshing is very important part of the finite element analysis, because with the selection of the type of element, the result of the component will get varied. Okay, so there are three types of elements used in the finite element method. First is the one dimensional element, which will be used for the rod, beams, trusses, frames. Okay, so one dimensional elements having only two nodes. So here you can check that there are only two nodes in the one dimensional element. So the basic example of the 1D element is the bridge structure, the towers where the mobile towers or electric towers. So these are the example of one dimensional element. Then second is the two dimensional element. Two dimensional element include the triangular element and quadrilateral element. Okay, so triangular element having 3 nodes and quadrilateral element having 4 nodes. Third one is the 3-dimensional element. So 3-dimensional is nothing but the use for the volume shape. Okay, so basic elements for that one is the tetrahedral element and hexahedral element. So tetrahedral element can be have a 10 to 12 node element. Also in the hexahedral element it will also be a 10 to 12 number of nodes. Okay, so the selection of tetrahedral or hexahedral is based on the shape and size of the geometry. So we will see in detail all the three types of element. So first of all, the line element, or we can say that the 1D element. A line element has the shape of a line or a curve. It may also be a line or it may also be a curve. Therefore, a minimum of 2 nodes are required to define it. So if you are seen in the bottom of the slide, that straight line has an it's indicated as an element, and that end points are the nodes, 2 nodes. Okay, so there can be higher order element that have additional node at the middle of the edge of an element. So that straight line indicates it's a linear element, and so curved line indicates it's a quadratic element. So quadratic element having an additional node at the middle. Okay, because it has a curved surface, therefore that additional node is required. An element that does not have a node in between its edge is called a linear element. The element that have nodes in between the edge are called as quadratic or second order element. Same in the 2D and 3D element. An area element has the shape of triangle or quadrilateral. Therefore, it requires a minimum of 3 or 4 nodes to define it. So in the triangular shape there are 3 elements, 3 nodes, sorry. In the triangular there are 3 nodes at the end, but for the quadratic element, at each line there will be a the middle at there will be a node at the middle of the line. Okay, so if we can say that for the triangular element there will be 3 nodes, but for the quadratic element there will be 6 nodes, and for the quadrilateral, for linear quadrilateral element there will be 4 node, and for the quadratic element there will be 8 node. Then volume element we can also say that it's a 3D element. A volume element has the shape of hexahedron, that is 8 node, wedge 6 node, and tetrahedrons 4 nodes. Okay, or a pyramid, it's a 5 node. Okay, so this is for the linear element, and for the quadratic element, it will be doubled. Okay. So these are some example of that 1D, 2D and 3D element where that element has been used for the analysis purpose. First is the example of tower. This is an example of tower where for the analysis purpose we can use a one-dimensional element. Okay, so that numbering is shown as it's an element. Numbering in circle indicates as an element, and numbering without circle is indicated as a node. Okay, so for the tower structure we use a one-dimensional element for the analysis. But in the second figure, it is a plate. It is just like a spanner. Okay, so we for this structure we will use the triangular element, that is 2D element. You can also use the quadrilateral element, but for the irregular shape the triangular element will be the best. Okay, and for the regular shape the quadrilateral element is best. Okay, so it's a 2D element, the use of 2D element, and it's obviously it's a 3D object, so therefore we need to use the 3D element. So here is also same. If the structure is irregular, you should use the tetrahedral element, and if the structure is regular, you should use hexahedral element. But please take note that the result of hexahedral or quadrilateral element are the best. Okay, the triangular and tetrahedral element will get oscillated due to its node, due to its edge effect at the node. So therefore the quadrilateral element always be the best. Two-dimensional discretization refinement. So this is the one example how the results will get vary in the finite element analysis. If you divide that plate, into the number of element, so that discretization with 228 element. First of all, you can see the example of 228 element. So the triangle is nothing but the triangular element. So and the corners are the nodes. But if you can refine that portion, because there is a hole inside that plate. So with the help of 228 element, it cannot be just you cannot find out the correct solution over that edge surface. So if you refine that body, you will see the exact circular portion over that plate, and also you can easily find out the stress concentration over that minimum area. Okay, so the refinement indicates the discretization with 912 elements. It will give the better solution than that 228 element. So development of finite element equation. So the finite element equation must incorporate the appropriate physics of the problem. For problems in structural solid mechanics, the appropriate physics comes from either strength of material or theory of elasticity. So the basics for that finite element equations is nothing but the strength of material or theory of elasticity. FEM equation are commonly developed using three methods, that is direct, variational or virtual work, or weighted residual method. Okay, so direct method is nothing but it is based on physical reasoning and limited to simple cases. This method is worth studying because it enhances physical understanding of the process. Okay, then variational or virtual work method. So it's an important method. It is mainly used in all the finite element analysis softwares. So variational methods includes principle of minimum potential energy method. So based on the concept of virtual displacement, leads to relation between internal and external virtual work and to minimization of the system potential energy for equilibrium. So we will see in the next lecture then how that equation will demonstrate for the principle of minimum potential energy. Okay, last one is the weighted residual method. Starting with the governing differential equation, special mathematical operations develop the weak form that can be incorporated into FEM equation. So weighted residual equations methods is mainly use the governing differential equations. This method is particularly suited for the problem that have no variational statement. Okay. So for stress analysis problems are Rayleigh-Reed's method or Galerkin method will yield a result identical to that found by variational method. Okay. So variational method is mostly used for the solid mechanics problem. Okay. So therefore we will go with the variational method. We already discussed the basic steps of finite element method, but here an equation of PMP or we can say that principle of minimum potential energy is discussed. So the equation is the K into U is equals to F, that is stiffness into the displacement is equals to the force. So how it can be written in the matrix form to finding out the unknown variables. So stiffness or a property matrix is written in the square matrix, displacement will be written in the curly bracket, and force will be written in the curly bracket matrix. Okay. So we will discuss now the how the 1D element matrix has been generated. Okay. So you can see here spring structure. Okay. If you consider 1D element having a single line and nodes at the two end. Okay. But here it is represented as a spring because every body has some stiffness property. Okay. Whatever the component, if you consider of whatever the material will be there, aluminium, brass, steel, wood, or whatever it be, every body having a stiffness property. But keeping in your mind, the spring have a stiffness property only. Okay. So therefore we represent all the element, we can also represent all the elements in the spring structure. Okay. So here it is represented as spring as nothing but the element, that stiffness value is indicated as K, having two endpoints, that is called as node 1 and 2. So the force is applied over F1 force is applied over node 1 and F2 force is applied over node 2, and we will get the displacement of U1 at node 1 and U2 at node 2. So from this figure we can find out an equation, the equilibrium at node 1, F1 is equals to that K into U1 minus K into U2. Okay. Because first of all we will apply the force at node 1. So first of all consider the displacement U1. So therefore K U1. Okay. So minus K U2. Thereafter equilibrium at node 2. So by considering the force is applied at node 2, so you just consider K U2 minus the displacement K U1. Okay. So it is written as F1 is equals to K U1 minus K U2 and F2 is equals to minus K U1 plus K U2. So it can be written in the matrix form as that from the first equation K U1, so K is positive, so here is K, minus K U2, so therefore is minus K, so it is minus K written as. In the second equation minus K U1, so therefore written as minus K, plus K U2, so it is written as plus K. Okay. So the displacement parameters are U1 and U2, so therefore in the curly bracket it is U1 and U2 is equals to, in the forces are F1 and F2. So if you are taking common K from this bracket, square bracket, so if K into 1 minus 1 minus 1 1 into U1 U2 is equals to in bracket F1 F2. Okay. So this is the basic matrix for one dimensional element. Okay. So we will solve the number of problems with the help of this matrix in the next lecture. So basic types of analysis are linear static analysis, non-linear analysis, dynamic analysis, linear buckling analysis, thermal analysis, fatigue analysis, crash analysis. Okay, so that type of analysis can be solved using finite element analysis. If any further analysis are there, that can also be solved. Some FEA tools or FPS software which involves all this type of analysis with the help of some names as static structural analysis, fatigue analysis, model analysis, harmonic analysis. Model analysis is nothing but the free vibration. Harmonic analysis is nothing but the force vibration. Transient analysis is the part of the dynamic analysis, but implicit dynamic analysis. Thermal analysis is obviously for the temperature. Explicit dynamic analysis and some other types of analysis are also can also be done in the finite element analysis software. These are some results with the help of static structural analysis. So static structural analysis is nothing but the if the body will get fixed at some point and the load is applied over that body, so that is nothing but the static analysis. We will get the result, a single result, not with respect to time. Okay, so whatever will be the calculation we are done in the design of machine element, that is the part of the static analysis. Okay, so you can try to solve that problems with the help of finite element analysis software. So here we will get this colored images are nothing but the contour plot. First is the displacement, second is the shear stress, third is the maximum shear stress. So that you can see that color bar in the left hand side, the blue is the minimum, then again that color zone has been increases, yellow green is the intermediate, yellow, orange and then red. So red is the maximum. So in the first figure the displacement is maximum at the upper point and the displacement is minimum at the lower point. Also in the second and third figure you can see that the red zone is at the inside diameter of the spring. So therefore the stress is maximum, always be maximum at the inside diameter of spring. Okay, this is an example of model analysis. So you can see in the second, third and fourth figure the B model, the frequency word is there. Okay, model, frequency. So frequency, so model analysis is used to find out the frequencies or natural frequencies over the body. So this is the structure of railway engineering. We are going to find out the frequencies at vertical, lateral and longitudinal side. Okay, so this is a model analysis. Model analysis indicates that we don't have to apply any load. We just fix that body at any one side. So you will get the frequencies. For example, if the tree is any tree is at the ground, any one of the free space, so it is fixed at that ground. Okay, and it is free at the top edge, that the leaves are moving here and there. So these are nothing but the free vibration, or we can say that it is freely moving anywhere. So that the displacement can vary, displacement can move in any of the side without applying any force. Okay, so that is the model analysis. Then fatigue analysis. So fatigue analysis can be indicated, can be expressed from its surface. Okay, what type of analysis is there, what type of failure is there, shear failure, tension failure or fatigue failure can be identified from its surface. Okay, so here the spring surface, actual spring fatigue zone is shown as here. That polished part indicates that it's a fatigue failure. Okay, so that in the fatigue analysis you can find out the life of any component, and also you can check the fatigue zone at its cross section. Okay, so these are the some introduction part of the finite element analysis. In the next lecture we will come with some numerical background and also some other methods. So thank you very much. Thank you.